Algebra Review Day 3. We're going to start with an opener, so you can go ahead and pause the video and do the first two on your own, A and B here. All right, let's see how we did. Solve for all solutions, meaning the real and imaginary solutions. So first thing I noticed, there's an x squared and an x. So I can't solve by square rooting. So I'm going to get it equal to 0 and try to factor it. So I'm going to add 6 to both sides. I have x squared plus 6x plus 6 equals 0. And now I'm going to try to factor it. So since it's 3 terms, I look for, I'm trying to factor it, I look for a GCF first. No GCF. Since it's 3 terms, I can make an organizational X and say, all right, A times C is 6 and B is 6. Do I know two numbers that multiply to give me 6 and add to give me 6? No. That means it's not factorable, therefore I cannot factor. That doesn't mean I can't do it. It just means I have to use the quadratic formula. All right, so quadratic formula, X equals the opposite of B, so that's negative 6. Remember, this is A, B, and C. So we have the opposite of 6, which is negative 6, plus or minus the square root of B squared, so in parentheses 6 squared, minus 4 times A, which is 1, times C, which is 6, all over 2 times A, which is 1. Time to clean it up. X equals negative 6 plus or minus the square root of, all over. All right, so we're going to do 6 squared, which is 36. And then we're going to multiply negative 4 times 1 times 6, which is negative 24. And that's all over 2. All right, clean it up even more by subtracting those two numbers. Remember, sometimes it's addition, sometimes it's subtraction. 36 minus 24 is 12, and then all over 2. All right, next step is you're going to go to your radical and see if you can simplify it. If you can't, you're done. If you can, then you're not done. All right, this is simplifiable. My perfect squares, 2 squared is 4, 3 squared is 9, 4 squared is 16. I passed 12, that is out. 9 does not go into 12. 4 does, and it goes in there 3 times. I can simplify root 4 to 2, so I'm going to change root 12 to 2 root 3. So I have x equals negative 6 plus or minus, I'm going to change the root 12 to a 2 root 3, all over 2. Last but not least, I'm going to see if it's furthermore simplifiable. If not, I'm done. I box my answers. So to do that, I'm going to look at these 3 numbers, and I'm going to see if they're divisible, if they're all 3 of them are divisible by the same thing. And they are. They're all divisible by 2. So 2 goes into itself once, 2 goes into itself once, 2 goes into negative 6, negative 3 times. All right, so now I'm ready to write my solution. X equals negative 3 plus or minus. I have 1 root 3. Instead of putting 1 root 3, you can say I have a root 3. Right? If you put the 1 root 3, that's fine, but it's just nicer just to put the root 3. And then all over 1. Remember, we don't ever put an answer all over 1 because it's anything divided by 1 is itself. And there are your 2 solutions. All right, let's move on to the next one right here. If you notice, I do not see an x squared and an x, so I can go ahead and solve by square rooting. In order to do that, I want to go ahead and isolate to where I want to square root. So I need to get rid of this plus 1 and this times 2. So we're going to use reverse orders of operations. We're going to subtract 1 from both sides. We have 2 times the quantity of x minus 3 squared equals negative 40. We're now going to get rid of this 2 by dividing both sides by 2. We have x minus 3 quantity squared is equal to negative 20. And now we can get rid of that square by square rooting. So we're going to square root plus or minus, square root plus or minus. We have x minus 3 is equal to plus or minus. And now we have to simplify the square root of negative 20. So I'm going to move this down just so I have a little bit of room here. So first off, I already see that it's a negative number, so I know I is going to be in my answer. So I can say, all right, root negative 1 goes in there and then cross it off and say it simplifies to I. Or I can say, all right, there is a negative root, so I'm going to automatically write down I. I know that's in my answer. And then I can simplify the root 20. All right, my list of perfect squares, once again, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. I passed 20. 16 does not go into 20. 9 does not go into 20. 4 does. It goes in there 5 times. The square root of 4 is 2. So what you have here is 2i root 5. All right, now we just have to get x by itself. We're almost there. I just have to add 3 to both sides. So I'm ready to write my answer here. I have x equals 3 plus or minus. We write this number first, remember, 3 plus or minus 2i root 5. And this is my final answer. If this was just a 5, if it was 3 plus or minus 5, I would do 3 plus 5 and 3 minus 5. But I can't simplify it any further. So therefore, that is my final answer. Okay. All right, so let's move on to the material we haven't covered yet. But once again, this is all review material. And we're going to do graphing quadratics. So we're going to graph quadratics in 2 of the forms. We have standard form and we have vertex form. So there's also intercept form, which we're not going to cover today, but it just means factor it and then graph it. All right, so standard form is in the form y equals ax squared plus bx plus c. And vertex form is in the form y equals a times x minus h squared plus k. So on vertex form, hk is your vertex, h comma k. And for standard form, to find your vertex, we are going to find the x value first by using the equation, the opposite of b over 2 times a. Okay, so let's look at this first example here. Graph each function and then find the requested information. So our function is f of x equals negative x squared minus 4x minus 3. So if you look at this, this is in standard form. So we're going to start off by doing is finding the vertex. We are going to find the x value of the vertex first. So to find the x value of the vertex, once again, we are using this equation right here, the opposite of b over 2 times a. So we're going to take the opposite of the b value. So we can see that the a value is -1, b value is -4, and c is -3. So the opposite of -4 is +4 over 2 times the a value, which is -1. Simplify that. That's 4 divided by -2, which is -2. So now we know the x value of our vertex is -2. Whenever you have an x value, you can always find a y value very easily by just plugging in the x to get the y. And that's what we're going to do. So now to get the y value, we're going to plug in -2 for x. So we're going to find f of -2. Plug in -2. So we got negative. That's this negative right here. And now we're going to plug in our -2 and square it. Then we have -4. We're going to plug in our -2 for x there. And then -3. All right, now we have to clean this up. Please make sure you are very careful of your orders of operations. Inside parentheses first. There's nothing we can do inside parentheses. Exponents next. So we do this next. -2 squared. -2 times -2 is +4. No more exponents. We move on to multiplication or division left to right. So this is, please keep in mind, this is a -1 times 4, right? So we have a -4 here. People ask a lot, they're like, wait, why is it +4? Because you're squaring the -2, then multiplying it by -1, okay? All right, this is multiplication right here. -4 times -2 is +8, and then we have a -3. Combine those and we get 1. So f of -2 is 1, therefore that's the y value. All right, we can graph the vertex right now. We have -2, -1, and that's the vertex of our parabola. All right, now we need our y-intercept. Remember what a y-intercept is. Our y-intercept could be like 0,5 or 0,3 or 1.5, or that's 1.5-ish, yeah. 1.5, but it's always 0 comma something. So we already know the x value, it's 0. And once again, if we have an x value, we can have a y value by plugging in that x value. So let's go ahead and get that y value. We're going to plug in 0. If you plug in 0 here, you get 0. If you plug in 0 here, you get 0. So notice it's just the c value. So we have 0, -3. We can graph that. 0, -3. Also, we have to keep in mind, since we know that this is the vertex of the parabola right here, there's an axis of symmetry that goes right through that point. And that means that any point is reflected over that line. So if there's a point here, there's also a point here. Okay, so we also know that there's a point at -4. negative 3. Okay, so I'm going to go ahead and leave that there because I know that there's a point there. So we actually could draw our parabola right now, but it does ask us for our x-intercepts. Now, just like I said, okay, our y-intercepts look like this. Our x-intercepts look like this, like 4, 0 and 6, 0 or 2.5, 0. Those are x-intercepts. Obviously, they're going to be somewhere in here, right? Okay, but there's something comma 0. And there's either going to be one of them, two of them, or none of them, dependent on how your graph looks. So how could there be only one? If my graph looked like this, there's only one. It's right here. If, I know that's very sloppy, but you know what I'm trying to do. My graph looked like this, there's none, okay? But I know that my graph looks like this, so there's going to be 2, okay? So let's go ahead and find out what those 2 x-intercepts are. Once again, there's something comma 0. So we're going to set y equal to 0 and solve for x this time. So we have negative x squared. I'm going to go ahead and erase all this stuff I drew on it so that I can actually see it. Negative x squared minus 4x minus 3. All right, so now we have to solve this. All right, so first thing I'm going to say is I can't solve it by square rooting because there's an x squared and an x. It's quadratic, right? So I'm going to try to factor it, okay? So I could try to factor it right now, but the first thing I notice is that there's a lead coefficient that is negative, and I'm not a fan of that. So what I could do is divide everything by -1 to get rid of that lead coefficient. Could I factor it the way it is right now? Yes, okay? But I don't want it. So I'm going to go ahead and divide everything by -1. 0 divided by -1 is still 0. X squared divided by -1 is x squared. Negative 4x divided by -1 is positive 4x, and then I have positive 3. The only reason I can do this is because I'm solving an equation. If this wasn't here and it just said factor that, then I wouldn't be able to divide everything by -1. I can factor out a -1. Actually, that's probably how I should do it. It would just make more sense, like, to be doing it properly. So I'm going to factor a -1 out of everything just to get rid of it, okay? Or not get rid of it, but so I don't have to worry about it. All right, so now I'm going to factor what's left inside these parentheses. So I am going to make my little organizational x. A times c is 3, b is 4. Two numbers that multiply to give me 3 and add to give me 4 are 3 and 1. And divide by a, which is 1. So I have x plus 3 and x plus 1. So I have 0 equals -1 times x plus 3 times x plus 1. So now I can set my factors equal to 0 and solve. I can set this, this, and this equal to 0. So let's go ahead and do that. I'm going to set, I'm going to set each one equal to 0. So I'm going to do x plus 1 equals 0, x plus 3 equals 0, and -1 equals 0. There is no x in this equation, therefore I can't solve it, right? So you could have skipped that too. If there was an x here, however, then you could solve it. So just be careful with that. I get x equals -3. And x equals -1. All right, so my 2 x-intercepts are -3, 0 and -1, 0. Graph those, -3, 0 and -1, 0. And you can see that you have your parabola, a downward-facing parabola that you can graph. We also know that it's downward-facing before we even started because if you look, the a value is negative, so that implies that this was a downward-facing parabola. Okay. Let's move on to the next one. Same directions, but this time, if you look, it is in vertex form. So as I said before, our vertex is HK. So if you look at the equation, H is in the equation, but if you notice, this is H right here. So there's a negative in front of this. So I'm going to tell myself the rule of take the opposite of whatever that. And here's K, and there's a positive in front of it. So I'm going to take it for whatever the value is. Okay, so we're going to come over here. We're going to get the vertex. We're going to say H. If you look, this looks like a -2, but remember, this is your H value, so it's a +2. And then our K value is -6. 2, -6. We can go ahead and graph that. 2, -6. All right, so now we would need to get our y-intercept. Remember, our y-intercept is always 0, something. So we know our x value is 0, so we're going to find f of 0. We're going to plug 0 into our equation. 0 minus 2 squared minus 6. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 6 is negative 2. So we have 0, negative 2. 0, negative 2 is right here. And then remember, there's an axis of symmetry. It's dashed, okay? So I'm going to end up erasing it too, but it's right there. That means that there is a point on the opposite side, or reflected over that line. And I'm going to erase this line that I put here because the axis of symmetry is dashed. We don't want to leave that there. All right, so last but not least, we need our x-intercepts. Once again, if you think about this beforehand, okay, sloppy, but it's okay. We know that we're going to have 2 x-intercepts. Please do not assume it's 4, 0. Mine is very crooked. In fact, it's definitely not 4, 0 because it can't be directly above this point, right? But we're going to have 2 of them. Okay, so I can say something comma 0 and something comma 0. All right, so y is 0. Let's set y equal to 0 and solve for x. So we're going to say f of x is 0, or y is 0. And then we have x minus 2 quantity squared minus 6. All right, so now we need to solve this. There's not an x squared and an x, so we can solve this by square rooting. We just have to isolate our x minus 2 quantity squared. So we're going to do that by adding 6 to both sides. So now we can get rid of that square by square rooting. Don't forget to do plus or minus. So now we have plus or minus root 6 is equal to x minus 2. And last but not least, we have to add 2 to both sides to get x by itself. So we have x equals, remember we write this number first, that's a positive 2, and then the plus or minus root 6. We can't simplify that anymore. If this was 2 plus or minus 6, I can say up 8 and negative 4, but it's a root 6. So it is a decimal answer, but we're not using our calculators for this. We're going to say it's 2 plus root 6 and 2 minus root 6. You could just write it as 2 plus or minus root 6, comma 0, and that would take care of both of your zeros, or sorry, both of your x-intercepts. Now, when I go to graph these, I'm like, oh, it's a decimal approximation. I don't know where it is. So what we're going to do is we're just going to make our parabola like so. I'm going to hold. Let's see if I can hold and make this nice. Yeah, I can. Okay. So if you look, I'm going to fix this just a bit here so that it's actually going through everything that it's supposed to. I don't have to get crazy. Okay, so that's good enough, right? But if you look, it's this point right here and this point right here. So I don't have to have dots there. It's just that I know that it's not a beautiful answer like 4 and negative 1, right? It's not negative 1, 0, and 4, 0. Okay, last part of this is practice. So if you want to pause the video and try these on your own, this is a good self-check here to say, have I been taking good notes? Do I know how to do these problems now that we've seen them a few times? All right, so here is me going through them really quickly. Write an equation of a line that passes through these 2 points. So I need to find the slope. I'm going to do y2, which is 5, minus y1, which is a negative 4. So I'm going to change that to plus 4. Over x2, which is negative 6, minus x1, which is a positive 6. So I have 9 over 0. I cannot divide by 0, so this is undefined. That means my slope, oh, that's a sloppy undefined. Undefined, okay? So that means my line is undefined. If my line is undefined, that means it's a vertical line. I also have the mnemonic device Vuxhoy to help me remember this. U stands for undefined. That means it's x equals. So this is a line x equals, and now I'm just going to look at the x values. They should be the same. Otherwise, I made a mistake. And I'm going to say that this is a line that goes through x equals negative 6. All right, the next 2 are solve each for all solutions. All right, so I want to solve this equation. The first thing I say is 5th degree. No, I don't say that, right? I say, all right, this is higher than a quadratic. That means first thing that I ask myself is it factorable? But it has to be equal to 0 in order to do this, okay? I definitely can't solve by square rooting. There's no squares in this. All right, so I say, is it factorable? Okay, so it's already equal to 0. I look to see if there's a GCF first. They both of these terms have an x in them. So I'm going to say, yes, this is factorable. So I'm going to say, okay, I'm going to factor out an x. I have x to the 4th minus 81. So now, remember, once you take out a GCF, you're still asking yourself, is what's left over in the parentheses still factorable, okay? So now I know that I have two terms. So I'm asking myself, is it a difference of squares, or is it a difference of cubes, or is it a sum of cubes? If not, I can't factor anymore. So if I look, it's a difference. And if I look, x to the fourth is a perfect square. It's x squared times x squared. And 81 is a perfect square. It's 9 times 9. So this is still factorable. I'm going to keep that x in front. And now I'm going to factor my x to the fourth minus 81. My first two terms have to multiply to give me x to the fourth, and they have to be the same thing. So x squared and x squared. And my second two terms have to multiply to give me 81, and they have to be the same number, just opposites. So I have positive 9 and negative 9. Now I could keep factoring, and I could say, okay, this is still factorable, but my end goal is to solve, and I know how to solve a quadratic, which that is. So I'm going to stop factoring and just move to solving. If the directions were factor completely, I would keep going. All right, so now I'm going to set each of my factors. Here's my three factors that I have, equal to 0 and solve. So I'm going to set x equal to 0. That one's done. X squared plus 9 equal to 0. And x squared minus 9 equal to 0. So the second two equations I still have to solve, but don't forget your x equals 0 in your solution set. I'm going to subtract 9 from both sides. Oh, wait, what I should have said, just to make sure everyone's okay with that. Got a quadratic. There's only an x squared. I can solve by square rooting. So I am just going to get that x squared by itself so I can square root. Square root both sides. Don't forget your plus or minus. X equals plus or minus. I know I is in my answer because it's the square root of a negative number. Now I just ask myself, do I know the square root of 9? I do. It's 3. So I have x equals plus or minus 3i is 2 of my solutions. X equals 0 as 1 of my solutions. So I have 3 so far. And now I'm going to get 2 more solutions. I can solve this by square rooting because there's just an x squared. I have to get x by itself first. X squared equals 9. I'm going to square root. Don't forget to do plus or minus. And I have x equals plus or minus. We know the square root of 9 is 3. 2 more solutions there. So I have 5 solutions total. Notice this was a 5th degree polynomial. That's no coincidence. All right, next solving here. So I have a quadratic, and I say, okay, can I solve it by square rooting? No, there's an x squared and an x. Can I solve it by factoring? It's equal to 0, so I'm going to try to factor it. 2 numbers that multiply to give me a times c is negative 6, b is 2. 1 and 6 won't work. 2 and 3 won't work. Not solvable by factoring. Therefore, I have to use the quadratic formula. X equals the opposite of b, which is 2, plus or minus the square root of, the square root of b squared. So I'm going to put negative 2 in parentheses and square it, minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is positive 1. All right, so we have x equals 2 plus or minus square root of, I'm going to clean up those 2 numbers. Negative 2 squared is positive 4. Negative 4 times 1 times negative 6 is positive 24, all over 2. X equals 2 plus or minus the square root of, I'm going to add those 2 numbers together, 28, all over 2. Next, I'm going to simplify this radical. I need to know if any of my perfect squares go in there. So I'm going to list my perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I passed 28. 25 does not go into 28, nor does 16, nor does 9, but 4 does. 4 goes into 28 7 times. Square root of 4 is 2. So root 28 simplifies to 2 root 7. X equals 2 plus or minus 2 root 7 all over 2. Look at these 3 numbers. They're all divisible by 2. So this is simplifiable. 2 goes into itself once, 2 goes into itself once, 2 goes into itself once. So I have x equals 1 plus or minus. I have 1 root 7 or a root 7. So I'm just going to write root 7. And then all over 1. And once again, we don't write divided by 1. You might be asking yourself, wait, why do we have to have this one but not this one? Well, that is like saying, like, I found $1. Well, I found $1 on the ground. That's this, okay? This is saying, that's a bad example. I'm going to take it back. So this is like 1. If I got rid of this, it'd be nothing. Hold on, let me get my eraser. If I got rid of this, there'd be nothing there. Okay? So I'm changing 1 to nothing. If I got rid of this one, oops. If I got rid of this one, that says there's 1 root 7. That still says there's 1 root 7. See the difference between the two? I don't know where I was getting that dollar example with. Okay, so there's my 2 solutions. All right, last but not least, I have this problem here where it says square 4 minus I. Remember, when you square something, you're multiplying it by itself. So I'm going to write 4 minus I out twice. And now I'm going to multiply it. 4 times 4 is 16. 4 times I is negative 4I. Negative I times 4 is negative 4I. And negative I times negative I is positive I squared. I squared is the same thing as negative 1. So this is the same thing as a minus 1. And now I can clean this up and write my final answer. 16 and negative 1 is 15. Negative 4I and negative 4I is negative 8I. And there is my final answer in the standard form of an imaginary number. All right, that's it for today's notes. You can go ahead and get started on the homework.